Now we're going to move on with our second opening keynote, that is Mark Mohr, who is Senior Vice President Vehicle Development at AB Volvo. And he's going to talk about...
Yeah, Mark will talk about the growing software and hardware complexity in this platform, but how this now eventually becomes an enabler for sustainable transport solutions. So, welcome on stage. Please give him a warm welcome on stage here. Here.
Thank you all. Thank you for that great passionate speech about strategy, sustainability, and how to bring it together. And I think it's a perfect link to what I will present, how to bring this together in a big company and how to link it to software. So I try to make a bit the bridge between these topics and what is following up later in more details in this session. So I will stay on a certain level of management speech, but I think I can link it pretty well. So Volvo Trucks, Volvo Group, we have an important piece in transport industry. Our trucks are an important element to make sustainable transport. And it's super important. And what we have heard before is you have to look into the future and you have to act now to create the basis to be able to deliver, to be able to give the opportunity to shape, to work with elements you do not think that they will contribute 2040. But you need to have the infrastructure. It's super important to be ready to do it. And we have realized it does not work in the way we have set it up, our infrastructure, our architecture on hardware and software side. And hardware and software are linked together. They are super heavy linked together today. We try to decouple them, but we will not be able to decouple them fully. Every one of you is used to drive a car. Often we are confronted that a truck is just a bigger car. So I will start in my first slide to explain a bit more what is a truck, what is our special challenge. And I'm a truckie since I'm a young boy, so it's my passion, and it's my passion driving it forward. And it's also super important in our company, it's our passion of our employees. And that helps to make also sustainable solutions. So if we look into our product portfolio, compared to what we see in other markets, our main task is to provide our customer with a tailor-made solution for his transport need. And not only in Europe, we are a global company. We have 2 different brands working in all regions of the world with super different needs, with different outside conditions. And then we have a huge number of different tasks and applications to fulfill. We have to support with our portfolio, with compared to passenger industry, a super small volume. So we have to be clever how to set up platforms, how to manage complexity. So our business is to handle variance. And that has a super huge impact also on how do we have to set up our architectures, starting from the vehicle, going over hardware, actuators, but then also electronic hardware and software architecture. So that is also a big driver for us and a difference, and that makes the beauty of that industry. And it's very hands-on. We are in touch with our customers. We have to understand their needs to provide the right solution. And then top-level strategy. Volvo has a strong focus on sustainability. We have a certain responsibility for the society. So we want to have 100% safe vehicles. It's a journey. We will not be at 100%, but we are going forward. We are aiming for having 100% free, fossil-free transport. That's our goal, that's our long-term vision, and we have a clear plan how to reach it. But also to reach it, it is super important because our vehicle is only a small piece in a logistics system. And you can make a lot of improvements on the vehicle, but productivity in the system has a bigger lever. And I think that's something we also have to aim for to be sustainable. It might not be a good business case for us to produce only half amount on trucks, but it can be a big lever to have a sustainable transport solution. And we have to find our place in such a scenario. So how do we want to reach 100% fossil-free? We also have all these activities to track our supply chain. We are working heavily on fossil-free steel because in a truck, around 70% of CO2 emissions from production is coming from steel. So it's an important lever we are acting on. But on the other hand, if I drive a 40-ton long-haul truck, around 800 to 1,000 kilometers a day with 30-liter fuel consumption, and that's then a pretty good one. I have a super big lever on how to get my energy consumption down on my vehicle. So that's one of our main tasks, and it's task of my team to work with that. As we have discussed, we have the spreading between short-term needs and long-term vision. And we have a clear long-term vision that says we want to provide with our vehicles 2040 zero emission CO2 emission transportation. As our vehicles normally have a lifetime of 10 years, to reach that, we have to sell earlier a high amount on zero emission vehicles. As we have a huge range of applications from a 7.5-ton city distribution, operating 100 to 100 kilometers a day, not a big problem with electromobility, to, in Sweden, 74-ton truck-trailer combination, operating 1,000 kilometers per day, not reachable. Some far ahead regions with electromobility, we have to utilize different technologies to reach it. So we are working on battery electric vehicles. We are super proud to be market leader in Europe, have a strong position in North America. But honestly, today we discuss about 100 to 200 trucks a year. So we still have to grow it, but it's an important pillar. We see hydrogen as an important enabler for CO2-free emissions. And with this fuel cell, but also fuel cell has its limitations. Super tough on cooling. And we also see that we will not reach, from today's point of view, our toughest application with the fuel cell truck. So we still will have a need for combustion engine, and combustion engine can be driven by hydrogen, can be driven by biofuels, and that's a portfolio we have to have in the future. And like you have mentioned, Niklas, we do not know everything now. We need to have this flexibility to play with all of our pillars to reach it. And we do not know what is the share. The share might be super different in different regions. So we need that enablers to deal with that variety also on the driveline. On the other hand, 2040 is far away. And we somehow have to track that we reach it. So we have started from this year onwards to follow our curve, to have it as an important guideline. And to reach that, we can not only work on the future technologies, we have to improve what we have out every year. We have to get better and better, and we have to balance that out. So that's our surrounding, our boundary conditions. And how is that impacting then software development, and what is the key enabler software development brings? If we look into our past and the upcoming future, I would say, we have started with mechanical component optimization. We have squeezed out a transmission to be super efficient. We have worked on an engine isolated to get better and better. But we have reached somehow the limits. So next step was subsystem optimization. And there electronic kicked in relatively early to control transmission, to control the engine in a much better way to get more and more efficient. But also that is not enough anymore today. So we have to start to combine different actuators, different systems. And we have to add to that component control layer in the software and in the architecture a tactical layer. We have to know how to use what. Can I use a climate compressor downhill to cool down by 1 degree my cabin, that the driver is not feeling it, but to store energy with something like that? Has a big impact, but we only can do it if we have a layer that is deciding, is it feasible? Does it bring a benefit? So we added that on vehicle level optimization, and therefore I need an additional layer in software. And software is the key enabler. I cannot do it by mechanics. So that's the way we have been going forward. And then we have started, and we are doing it more and more, to connect the vehicle with the surrounding. Getting the information of topography. Being able to use 40-ton energy downhill in the right way, not to burn fuel, not to burn energy on a battery. How to manage that, a first step. So we are working with, I would say, a vision of, I know what is coming in 10 kilometers and I adapt to that. But that's not enough. I have a certain traffic situation. And I'm in a lucky situation that I have sensors for driver assistance systems on board, which are controlling what is happening in the near field. So in the next step, I can take this in account as well. So I need to connect the vehicle to the outside. I need to get informations in. I need to get information out. I have to support other road users to control the flow. And then for us, more important than in a private transport is we are just one part of a flow. A product has to come from a place A to a place B. There is a lot in between. There is handling of containers in between. There are vessels in between. There are traffic jams in between. So we have to connect, and we start to connect more and more with the complete transport flow to optimize the system, to create efficiency, and with more efficient system, I create also sustainability. So we also see more software offboard. If I plan a route for a battery electric truck, where I have certain limitations, where I need to know where I have a charging station, I will do that offboard. And I have to get the offboard information to my truck. And there also software plays an important role. So we see software as a key enabler. It's a key element today in our industry. It's a big focus on our engineers to do it, to combine it with the hardware. But it also has been growing. We have started 15, 20 years ago with some small pieces. We have evolved, we have optimized, we have tweaked, we have made everything better. And then we have reached some hurdles of ECU capacity, of memory, and we have super good engineers. They have been creative. They have started to place the software function somewhere else where it might not belong to, but we have some storage. So what we have created is a huge complexity. That's our current software code complexity we have. Sometimes by intention, sometimes by accident. We have to clean up. But with the first picture I've shown, we never will get it uncomplex. We always have to be able to manage complexity. And that's also, I would say, a key competency of us. So we have to take this in account, we have to optimize it, we have to structure it in a new way, and we have started. Then what we see today, and we will have it always, is we have a certain connection between software and electronic hardware. And in our case, also in addition, a bit more than in the PESCA industry, regarding vehicle architecture. So one of my learnings as I stepped into the truck industry is I have to tilt my cap. And there is a small connection. And through this connection, I only get a certain number of cables. So even if I would like to have a fully centralized architecture, I will not be able to get all signals to my chassis. So we are a bit more forced in working also in zone architectures and combining centralized, more powerful architectures together. But you have to know it to make the right decision. So it's always a link between vehicle architecture, hardware, software we have, and we cannot disconnect it. And then, working with software, we need to have a good backend. We need to be able to test. And in this huge number of variants we have out in different use cases, we are not able to test everything on the truck. We are not able to test everything with a team in Gothenburg. We have also to rely on simulation. We have to get much more data out and experience from our vehicles in the field. We have to use them. We have to create shadow modes. So we have also started that journey. And also then complexity. You cannot manage in the old way of working because you are not able to predict everything. Something will happen what you have not expected. You can be as good as you want, it will happen. So you have to be able to react fast, even if you have long lead time for certain elements, but you have to be able to react fast. So agile and a new way of working is super important. And we have to combine it with a super traditional way of testing and homologating trucks. If I need for a certain feature a winter test, I need more than 1 year lead time. No discussion. Even if I could make the software in 2 minutes, I have a certain lead time. If I need to drive a homologation, homologation says you are just allowed to make some variations on the software. If you make a bigger change in the software, you have to re-homologate. It takes time. So we have to bring these timelines together, and that's super crucial. So I think we have seen that we have these challenges and we have reacted. So reduce complexity, but handle it. Work with complexity, it's one step we heavily have invested. We have started to establish clear interfaces. We use more simulation, more process digitalization. It's super important. And we try to reduce hardware complexity and dependency on hardware, but we will never get rid of it. I'm super proud of my team. I have not seen it before in the industry, and I'm relatively new at Volvo. We have reached on the software side super fast development cycles. We are in 2 weeks cadence, where we are able to bring out improved software to the production. In some areas, we test our results daily. It's a super good organized cadence. But we are not on the end. And we also have to support the guys to enable this globally. And then this different speed we have in development. It's a huge challenge. And it's a mindset also. And understanding each other. The ones which are responsible for hardware, for testing, they know why they do certain things, and the other one has to accept it. But they also have to know, if I'm not dependent on something like that, I need to be able to approve a new software in 2 weeks. Yeah. It was also clear for us now, it doesn't work anymore how we have set it up, our architecture. So we needed to cut off, and we need to do it now. And the team has worked more than 10 years now to come to that point. And it will take some time to be ready to enable future improvements. So we have done this with a clear focus on, we have a function and a customer feature-based software architecture. That's super important for us. That's in the center. We try to reduce the efforts for software integration by decoupling different software layers. And starting to separate a bit more hardware from software. But we have been super traditional that on the actuators, the software is, which is controlling the actuator to all layers. We will have an ECU on actuator still, but he will have a different task. We install more computational power and bandwidth in our communication now. We will not need it next day. We will need it somewhere in 2030, but we have to do it now to be flexible. And we need to utilize agile methods because we have some processes running in years' time. We have some ones just taking months, and we have other ones we can do in days or minutes, and we have to bring this together. And super important for all of us is our passion for trucks, sustainability. My team is so proud to drive sustainable solutions. That is the only chance to combine a vision from the top with to execute it. And we are super passionate to make good software. So, thank you.
Thanks a lot, Mark.
Perfect ending.